Good morning. Welcome to week 5 maths. We're starting a new area of maths and we're getting into patterns and algebra. First lesson today is a pretty big one actually, so get ready for some hard work. You need to concentrate. Now I will say there's a lot of good learning to happen here and we've got a few new concepts to start covering. But in this particular lesson, it will actually be of benefit for you if you have a calculator. So if you want to pause the video and grab yourself a calculator, you can. The calculator will help you to do some of the harder calculations and not get bogged down with that part, because it's actually other things about the conventions when we look at the order of operations that you need to learn rather than getting caught up with how to calculate. So pause the video and grab a calculator. Alright, if you don't have a calculator, I guess you're just going to have to do your very best. So today we're going to explore and apply conventions that are used in or when we're calculating expressions that contain multiple operations. And by that I mean, if you have a look at our example at the bottom there, 7 plus 6 times 4 has two operations in it. It has an addition and it has a multiplication. So it has two operations. Most of the time when we do calculations, we're only doing one. This particular case, we have two. So, it's different to a normal calculation where we're just doing addition or something like that. So, another term that they're introducing there is the term expression. Now, basically, an expression is a combination of numbers and symbols, as we have in that example. All right, let's move on. Alright, so we're looking at order of operations. What is a convention is the first question. So basically a convention is a rule, and you need to remember that. Conventions are standard ways of doing things. So it is the way it must be done. You've got to remember that. So you need to commit yourself to learning these conventions. If you commit yourself to learning them, it's going to be much easier when you're doing the order of operations. So it's the standard way that tells us the order in which to calculate the operations when we work on expressions with multiple operations. And we call it the order of operations conventions. And if we apply these, then it ensures everybody gets the same answer. So let's explore what we're talking about there. Here we go. So there are three basic conventions that we need to look at. One, and this is the first one to always remember, do calculations inside brackets. As soon as you see brackets, they are always done first. No matter what's inside those brackets, do the brackets first. Convention number 2 is we do multiplication and division before addition and subtraction. So I often talk about how strong signs are, and I say multiplication and division are stronger signs than addition and subtraction, so we do them first. The third one says work left to right. Now if you think about that, working left to right, like we read left to right, it seems to almost go against the second one. But actually the way you need to think about it is it goes hand in hand with the second one. And by that I mean if you have an expression with both multiplication and division in it, then you work from left to right. So if you have a multiplication followed by a division, then left to right you do the multiplication first, then the division. Similarly, if the division comes first and a later expression is multiplication, then you work left to right. And the same if it has an addition and a subtraction. Do the one on the left before you do the one on the right, no matter what order it's in. We'll explore that a little later on. Now let's look at the expression here. 4 plus 6 times 9. Because multiplication comes before addition and subtraction, we do the multiplication first, even though it's on the right in this case. 6 times 9 is 54 plus 4. Because multiplication is stronger than addition or has more, it's in the convention we do it first, then it must be done first. It would be a totally different answer if I did the addition first. 4 and 6 is 10, times 9 is 90. 90 is nowhere near 58. It must be done first. The correct answer is 58, not 90. Time for you to explore a bit more. So we're going to explore left to right for the moment, and in this particular case it's left to right with repeated addition. So these expressions only have addition in them, and what we'll find is regardless of which operation is calculated first, the answer will be the same. So if it's 4 plus 6 plus 9, if I do the 4 plus 6 first, that gives me 10, 10 plus 9, 19. If I do 6 plus 9 first, to give me 15, 15 plus 4, 19. The answer's the same both ways. In A, which is done for you, 12 plus 5 plus 10, 12 plus 5, 17, plus 10, 27. Or, if I add the 10 and the 5 together to get 15, 12, add 15, still gives me 27. Pause the video to work through examples B, C and D, and what you should be finding is the answer does not change. Pause the video now and let's see how you go. Alright, let's check. If I add those together first, I get 15, 15 and 14 is 29. If I add 10 and 14 together to get 24, when I add the 5, still 29. Same in C. No matter which addition I do first, I'm going to come up with an answer of 27. And in D, no matter which addition I do first, I'm going to come up with an answer of 28. That's what you should have found. Now, order of signs, when we have the same expression repeated with addition, it won't change the answer. Addition's fairly easy in that way. The other one that's like that is multiplication. So where addition, it doesn't matter the order, multiplication, it doesn't matter the order either. So I've got 4 times 2 times 3. If I do 4 times 2 to get 8, 3 8s are 24. And in the second way of doing it, 2 3s are 6, 4 6s still give me 24. So if it's repeated multiplication, the answer will be the same. Don't forget, if you have a calculator, it's how you use it, or it's using the calculator. That's fine. It's learning what the understanding is here. Okay. Pause the video and do B, C and D for yourself because A is already done. Let's see how you went. 4 times 22 is 88, double 88, 176, which is going to be the same no matter what order. In C, 112 or 112, fancy that. And in D, 960, 960. I hope you did have a calculator to help you there because these numbers are getting large. But the whole idea is that you can see the order in which the multiplication is done doesn't matter, it doesn't affect it. So see if you can answer question 3. What have you noticed when calculating expressions containing repeated multiplication, such as here, or here, or here? What do you notice? Okay, let's see what you wrote. Something along these lines. It doesn't matter if your wording's a little different. The answer is always the same, regardless of the order in which those operations are calculated, meaning the repeated multiplication. It's the same no matter what. Now, as you can see, the order in which the operations happen when doing addition and subtraction don't influence the answer. It's the same both ways. However, it's going to be completely different with subtraction and division. So subtraction and division definitely will matter, as we'll see here. So let's have a look at the two expressions at the bottom of the page, or the expression at the bottom of the page, which involves subtraction. We've got two subtractions here. If I do 48 take 8 to get 40 and then take 5, my result is 35. Whereas if I do this subtraction first, 8 take 5 is 3, 48 take 3, the answer is 45. The answer is quite different. Subtraction, it matters. And so that goes back to that convention of working left to right. The correct answer is this first one, working left to right. Subtraction is repeated. We must work left to right. Even though it didn't matter for addition and subtraction, it probably is a good habit to get into to work left to right. What about division? Well, let's have a look. I'm going to say yes, it will affect. So 16 divided by 4 equals 1. So 16 divided by 4 is 4. The red one or the pink one's done first. And then 4 divided by 4 gives us 1. In this particular case, if I was to do it out of order and do 4 divided by 4 first to get 1, then 16 divided by 1 is going to give me 16. Answer is completely different. First one is correct. Work left to right. So if it only involves one operation, we've seen that multiplication and addition doesn't really matter, but subtraction and division do. I'll repeat what I said before. Get in the habit of working left to right on those. However, if there's a mixture of operations, then things go in a different way. And that's where we really need to apply our conventions for order of operations. So I told you this lesson's quite detailed, and we've got a fair way to go still. So let's read what it says here. So far, we've looked at expressions repeating one operation a multiple of times. It might repeat addition, it might repeat subtraction, and so on. We know the order in which we calculate addition and multiplication doesn't matter. However, an answer will change or can change if it's a subtraction or division expression, depending on the order in which the calculations are carried out. Alright, so to help prevent any confusion, there are 3 conventions to follow to help us calculate the correct answer. And we're going to watch a video now which talks about that. Alright, so let's watch that video.
Order of calculating. So far, we have looked at expressions that repeat one operation multiple times, such as 4 plus 8 plus 2. We have recognized that when working with multiplication and addition, it doesn't matter in which order the operations are calculated. The answer will always remain the same. Let's look at what we know. 8 plus 5 plus 2. 8 plus 5 gives us 13. Add the 2, which equals 15. Or 5 and 2 gives us 7. Add the 8, which equals 15. We have also developed an understanding of how subtraction and division work differently. 21, subtract 7, subtract 3. 21, take away 7, leaves 14. Then take away 3 to give 11. However, another way some people calculate the answer is to find 7 take away 3 to get 4. Then 21 take away 4 to give 17. The 2 answers we have calculated are different. This method will give an incorrect answer. The remainder of the video will look at the conventions we use that will explain why this is so. We need to consider how we would calculate expressions containing more than one operation. There are conventions we can use to make sure everyone calculates expressions the same way. Do multiplication and division before addition and subtraction, and work left to right. Let's see how this works for the expression 45 take away 10 divided by 5. We do the division before the subtraction. 10 divided by 5 is 2. Then 45 take away 2 is 43. Let's look at another expression. 14 plus 5 multiplied by 6. Using the convention for calculating calculating, we do the multiplication first. 5 multiplied by 6 is 30. Then we add the 14 and the 30 to give 44. We have used two of the conventions that are called order of operations. They are do multiplication and division before addition and subtraction, and work left to right. We will look at another convention later in the lesson.
That's very important to be able to do that. You must remember those conventions. You must remember that addition and subtraction is after multiplication and division. And generally speaking, if it's not the same or if there's a repeat of those, you work from left to right. Tuck that away, remember it. All right, let's apply that understanding here. So here you've got addition and multiplication. Here you've got subtraction and division, multiplication and addition. So there's a whole range of things here. Now you've got to calculate these and you've got to do them in the right order, applying the right conventions. So remember, multiplication and division first before addition and subtraction. Have a look at E, which has both division and multiplication. Because they are done before subtraction, work left to right. Here, work left to right. So do this one first, do this one second, and do this one last. Multiplication and division before addition and subtraction. So do the division, do the multiplication, then do the addition. All right, have a go at those ones. Pause the video and do those 6 examples for me. Okay, I hope you were confident with that. So you should have done 6 times 2 is 12, plus 12, 24. In B, division first, before subtraction. 10 divided by 5 is 2, 46 take 2, 44. In this one, the order is the same as you'd do it if it was left to right because multiplication is before addition. 6 2s are 12, 12 and 8 is 20. Here, I hope you remember to do the division first in D. So 10 divided by 5 is 2, 45 plus 2 is 47, take 1, 46. E, division and then multiplication. So 50 divided by 25 is 2. 2 times 50 is 100. So there's the 2, which came from this calculation, multiplied by 50. So 2 times 50 is 100, 150. Take 100 is 50. This one first, this one second, addition third. So 48 divided by 2 is 24. Then we have to do the 6 times 2, which is 12. And when we add, as the final thing, 24 and 12, we get an answer of 36. How did you go? It might take a bit of practice, a bit of revision for you, going over examples, but there are conventions we must follow. And we're now going to look at the next convention, the convention involving brackets. Probably the easiest one, really. So if you've got those other ones down pat, this one's probably the easiest. All right, let's have a look at this video now.
Writing expressions using brackets. We have looked at some of the conventions for the order in which operations are performed. They are to calculate operations in brackets first, to calculate multiplication and division before calculating addition and subtraction, and then to work left to right. These conventions help prevent confusion. They provide us with one clear set of guidelines for solving expressions containing multiple operations. Let's read the question. Every week, a paper boy delivers 45 papers in Court Street and 43 papers in Dolby Street. How many would he deliver in 6 weeks? The expression for this question has more than one operation, so brackets may need to be added. You might write the expression as 45 add 43 multiplied by 6. However, the conventions would lead us to calculate the 43 multiplied by the 6 first. We need to add brackets to ensure the expression matches the events occurring in the question. We know that 45 add 43 gives us 88. Then we calculate 88 multiplied by 6, which gives us 528. Another way we could write the expression is 45 multiplied by 6 add 43 multiplied by 6, because we have 6 lots of 45 papers and 6 lots of 43 papers. There is no need to add brackets to this expression because the conventions lead us to calculate the multiplications first. 6 lots of 45 gives us 270, and 6 lots of 43 gives us 258. We now add these two amounts together to obtain 528. We then write a sentence that explains our answer to the question. The paperboy would deliver 528 papers in 6 weeks. Read this question with me. Caitlin has 56 collector cards. She lost 12 cards. She shared the remaining cards among 4 of her friends. How many cards will each friend get? When writing our expression, we might write 56 subtract 12 divided by 4. Using the conventions would lead us to calculate the 12 divided by 4 first. This would not match what the question describes. We need to add brackets to see how many cards Caitlin had before sharing them among her friends. Pause the presentation while you calculate the answer to this expression. 56 take away 12 is 44, and 44 divided by 4 is 11. Write a sentence to show the answer to the question. Let's look at another question. Tickets to the tennis cost $20 for adults and $12 for children. Reese's mother took him and his 2 friends. How much did the tickets cost for the 4 people? One way we might write this expression is 20 add 12 multiplied by 3. We could write the dollar signs in the expression, but this is not necessary, as long as we remember to include the dollar sign in our final answer. Brackets are not necessary in this expression, as our conventions lead us to multiply before we add. Pause the presentation while you calculate the answer to this expression.
Okay, so if you've paused it, or if you've done your calculation, how many adults? There's only 1. How many kids? Reese, 2 friends, that's 3 children altogether. So as it said, there's no bracket needed because you do this part first. See how you went.
12 multiplied by 3 is 36, and 20 add 36 is 56. Write a sentence to show the answer to the question. Remember, the question gives costs in dollars, so we make sure we give our final answer in dollars.
So you need to actually think about what's happening in the story when you're writing the number sentence that goes with it. That's a very important skill, to be able to write the expression or the number sentence to match a story. All right, let's continue.
Let's do one more question together. Leah bought 4 hairbands at $5 each. Joanne bought 2 magazines at $4.50 each. How much did they spend altogether? Pause the presentation while you write an expression for this question.
Okay, so 4, lots of $5, 2 lots of $4.50, and then you need to add them because it says how much altogether. All right, have a go at writing that expression. Let's see how you went.
One expression you might write is 5 multiplied by 4. Add 4.50 multiplied by 2. There is no need to add brackets as the conventions lead us to calculate the multiplication before we calculate the addition. 5 multiplied by 4 is 20, and 4.50 multiplied by 2 is 9. Adding these two answers together, we get 29. Write a sentence to show the answer to the question. Remember, the question gives costs in dollars, so we make sure we give our final answer in dollars.
Okay. So the new convention is calculate operations in brackets first, but there's got to be a reason why that's happening. There has to be a reason why you need to do that calculation first. So our calculation, or our expression at the top, has 80 plus 30 in brackets, divided by 2 equals 55. So if we've got this story here, Grandma sends Yuan and Huang $80 for a show. Grandpa sends them $30. They share the money equally. So we've got $80 from Grandma, $30 from Grandpa, and sharing equally among 2 people is dividing by 2. So if they're sharing the total money equally, we need to add the money first. Yuan has to spend, or how much does each child have to spend at the show? We write an expression. Well, there's the expression. It's at the top. That's giving us our answer. So getting a bit of practice with writing the number sentences is important. Let's have a look. So if we use the information from the previous question and we write a story something like this, if we didn't have the brackets, we'd end up with the wrong answer. So if we apply the 2 conventions we already learned earlier, we'd end up with 95. 30 divided by 2 is 15, 80 plus 15 would be 95, and obviously that answer is wrong. So we know it's incorrect. We need to end up with the answer of 55, not 95, and so we need to add the brackets in. So the new rule for the order of operations is calculate expressions in brackets first, then solve any multiplication or division and work left to right. And the third thing is then solve any addition and subtraction, working left to right. All 3 conventions work together to help prevent confusion. I'd actually like you to pause the video and read this box through and build your understanding of it. So do that for me. Pause the video and read that through. I really hope that you have an understanding of that, because this is the key to it all. So now I want you to calculate through each of these. Some contain brackets, others do not, but brackets first, followed by multiplication and division, left to right, addition and subtraction, left to right. Pause the video and see how you go with this exercise. Okay, good luck. Let's see how you went. 12 and 4, 14 is 26. 26 divided by 2, 13. Multiplication, subtraction, multiplication. We do the multiplications, then the subtraction. 5 tens are 50. 3 sixes are 18. 50, take 18, 32. In C, there is a multiplication, a subtraction, and addition. 8 twos are 16. 33, take 16 and then add 4. Well, 33 take 16 is 17. 17 add 4, 21. D contains a bracket, so we need to do this bracket first and then multiply. So 50 take 16 take 7. or 50 take 16 34. 34 take 7 is 27. 2 27s, 54. Bracket. 3 and 2 is 5. 4 times 5 is 20, so 69. Take 20 is going to give us 49. And in this last one, multiplication, division, division. Now, this bracket here tells us it must be done before this division here. So 108 is the result of 54 times 2. 24 divided by 12, the result of that is 2. So 108 divided by 2 is 54. How'd you go? I hope you were confident with those. It does take practice. It will take practice. You need to practice to get better before this becomes, I guess, an understanding that you just apply all the time and easily. All right. It was a fair bit of learning today. How did you go? I hope that your confidence is growing. We will, over the next lessons, keep practicing those skills. But that was a good practice for the day. I hope that your confidence is growing, and remember those conventions. It's very important. All right, guys. Thank you. Done for today. I'll catch you tomorrow. Cheers now.